From the beautiful South Studios of Way Happy, this is Mr. Meyer and 1-1, a preview of calculus. Now, what does this mean? This is a pretty weird section, or just not your typical math section. It has a lot of reading. You might want to flip in the book and just see how beautifully they compare pre-calculus and calculus. And what they mean by pre-calculus is anything you've done before calculus, not just the course that we think of. And then they talk about, just a little bit, two very popular problems in calculus, and they just kind of introduce you into what we're doing. And so here goes. I will just kind of sum up some things and talk about those two problems and leave you to read and look at my notes, and you can see what I thought was important out of that chapter. All right, so what is calculus? Calculus is the study of change, right? And so we talk about acceleration and tangent lines and slopes and all that stuff. Now, you did that in pre-calculus for sure, but in pre-calculus, things weren't changing, and in calculus, things are. Like if I drive to Disneyland, in pre-calculus, I would tell you how long I drove and how long it took me, and you can tell me how many miles per hour I averaged. But in calculus, we're kind of curious more about the entire trip and maybe where I was accelerating and decelerating in the trip. Like you could tell as I'm getting onto a freeway, what's my speed as I am slowly getting on. I'm not going 60 miles an hour the whole time. When I got in the car, I started off at 0 and I accelerated rapidly up to 25, and then I cruised at 30, and then I accelerated to 55 as I got on the freeway. And so that's what calculus is. It's a study of this changing speeds rather than just saying, hey, you averaged 60 miles an hour to the trip to LA. And that's what this is saying. There's some examples you can see in the red section there that say an object traveling at a constant velocity can be analyzed with pre-calcs, but to analyze it accelerating, you need calculus. And all these different ideas like that. The area of a rectangle can be done in pre-calc, but if you want to find the area under a curve, you need what's called calculus. And all of these kind of follow the same rule. You got to have a basic understanding of how to find certain things like area and slope. You have to know how to do that. But then we're going to mess with it and call what's called the limiting process, where we're going to almost make it illegal so it doesn't work. We're going to divide by 0, say, and you're like, it doesn't work. Well, we're going to get so close that we're going to make a good guess, and that's called the limiting process, and that's where calculus really comes from. So here's the tangent line problem that is very popular in the world of calculus, and I thought I could fit it all on one screen, but I can't. Now, say you have this curve right here that I'm going to highlight in yellow. You have this line right here, right? And the tangent line at point P, I want to know what the slope is of that tangent line. The tangent line is where it comes up and it hits the curve just once, right? And then it's gone, but it's a straight line. And I want to know the slope of that straight line. And you go, well, you can't. Well, guess what? Calculus says we can't. And what calculus does is in this second part over here, they say, well, you know how to find the slope of a line. So here's that point P right there. And we're going to pick some random point out here and connect that with a line. And that's called your secant line. So that's called a secant. That blue line that's drawn there, that's called a secant line. And you can definitely find the slope of the secant line, right? Because you got 2 points and you can find it. Now you go, wait, that's not the same as the tangent. And you're right. It's not the same as the tangent. But the cool thing is, as that random point that we picked, as we start to move it closer, maybe here, or if I move it here, if I start to move closer and closer, I should be able to get really good guess on that tangent line, which you can see right here, right? As you slide that point closer and closer and closer. In fact, we want to get tiny close. We want to get so close together that we should be able to get a really good guess of what that tangent line is. And that process of getting closer and closer and closer, once you get too close, right? If you just right on top of it, then your run is 0. And we all know slope is rise over run. And you could count the rise, but if the run is 0, we're done. And that's what the limiting process is called, where we're going to get so close that we're going to be like, all right, we don't know what it is, but we could tell you what it would have been if we wouldn't have divided by 0. And you'd be like, oh, nice. That's the limiting process. And that's how we can find what's called the tangent line. So I do a bunch of secant lines. I get closer and closer to the point that you wanted to know, what the slope of the tangent line was. And as I get closer and closer, all of a sudden I can say, hey, I'm really confident that this is the slope of the tangent line. All right, let me ask you a question. We'll come back. We'll wrap this up. Excellent work. Now, let's talk about the second classic problem in the world of calculus. It's about finding the area under a curve. Now, look at this nice drawing right here, right? I have this beautiful curve and a shaded region underneath it. And I want to know the area of that shaded region. Now, a good guess, and in pre-calculus, I would say, hey, let's make it a rectangle and let's just do length times width. And you're like, hey, that's pretty good. Would it be exact? No, right? I'm missing some of this, but I'm also didn't count, or I did count some of that. So hopefully it would kind of average out and be done. And that would be a really good guess. And that'd be about the best I could do. But what we do in calculus is we go, all right, well, let's see. Let's chop that area up into rectangles, right? And maybe different height rectangles. And that part you can see right here, right? So what you see is I could start making a bunch of rectangles and I could count them up. And again, you would see that if we added up, if we knew the length and width of these rectangles, then we could find the areas, just add them up. Still, we'd be missing this piece and we'd be missing this piece. And we've kind of overcalculated right here. But we got a pretty good idea, better than the first idea I had. Well, then somebody goes, well, let's make it even smaller rectangles. Let's, instead of chopping it up into such big rectangles, let's go smaller rectangles. And look, now they've really decreased what we're missing or what we're overshooting. And then somebody else is going to come along and say, wait a minute, let's make even smaller rectangles. And these rectangles start to get thinner and thinner and thinner and thinner. And oh my gosh, you got a million rectangles in there. And that would be awesome. That would be really hard to count up all these rectangles. So again, we could kind of use the limit process and to try to say, all right, we know where this limit is headed, right? I'm going to keep making these rectangles smaller and smaller and smaller. And I'm going to start to get an idea of what the area is. And then I'm going to make the rectangles smaller. And I'm going to get a better idea and a smaller and a better idea. And pretty soon those rectangles are going to be so tiny that it's not going to change that much. And I can make a good guess, or I can use the limit process to go, okay, here's what the area is, because I can give you a really good educated guess. Because as the more rectangles we get, the less area we're going to be missing. And that's our goal. And that is the area, or the second most common thing that they want to do in calculus, and that'll lead to integration. So the first one will lead to derivatives. This one will lead to integration. And that's kind of the idea of calculus. And now we get to spend time, the next 10 weeks, studying that and trying to figure out how to do it. And there's a bunch of different techniques, a bunch of different ways, but really, that's it. Hey, have a great day. Stay happy, and I'll see you tomorrow.